In this video, I'm going to be going through the Chapter 8 Polynomials Test Review Part 2 homework review, which is similar to the one that we did in class together. So on the front page here, we have some multiple choice questions. So the first one says, sometimes you can save time by factoring out the greatest common factor, or the GCF. Which expression below has a GCF? So again, we want to look at these four different expressions and see which one has a GCF. So looking at the first one, I have a 4 and a 25. There is no number that goes into both 4 and 25 besides 1. So that's not really what we're looking for here on this problem. For B, I have coefficients of 1, 15, and 36. Okay, there's, again, no number that goes into all three of those besides 1. So that's not really what I'm looking for. On C, I have a 3, a 5, and an 8. And again, on that one, there's no number that goes into all three except for 1. So that's not really what I'm looking for. But on D here, I have a 3 and a 18. And 3 actually goes into both of those. 3 goes into 3. 3 also goes into 18. And I also see that both of these terms have an x squared in common. So D here is the one with a GCF. On number 2, it says, which expression below represents the difference of two perfect squares? So just to remind you, difference means subtraction. So we're looking for the one with subtraction. So that means I can eliminate D right off the bat because that's addition. And then it says the two perfect squares, which means both of my numbers here need to be perfect numbers. So when I look here, I see 4 and 25. Those are both perfect numbers. 2 and 6 are not perfect numbers. Remember, perfect numbers are 1 squared, 2 squared, 3 squared, 4 squared, and so on. So 1, 4, 9, 16, and keeps going. So those aren't perfect, and neither are 3 and 18. So here my perfect, or my difference of two perfect squares is A, 4x squared minus 25. For number 3, it says, which expression below would you use factor by grouping? Okay, well, you use grouping when you have 4 terms. Okay, so really when it says factor by grouping, you're just looking for the one that has 4 terms, which in this case would be B. For number 4, it says, which expression below has an A value greater than 1, and therefore you should use split the middle. For split the middle, that's what we do when we have a trinomial or 3 terms. So first of all, it has to have 3 terms, which means I can eliminate A and D. So I'm left with just B and C. We also use split the middle when A is greater than 1. So looking at the numbers here, A in this one is a 1. A in this one is a 2, which means A greater than 1 is here when A is 2, so that's C. For number 5, it says, which expression below is a perfect square trinomial? Again, trinomial means 3 terms, so it has to have 3 terms, which means I can eliminate C right off the bat. Okay, and a perfect square trinomial means the first term is perfect, the last term is perfect, and then that middle term forms a 2ab. So let's just check each of these. I have x squared minus 6x plus 9. X squared is perfect. The square root of x squared is x, so x times x. The square root of 9 is 3, so 9 is really 3 times 3. And then if I check the middle term there, I have 2ab for my formula, so 2 times x times 3, which is 6x, which is in fact my middle term. So this one right here is actually my perfect square trinomial. Then for 6, it says, which of the following is the complete factorization of 25x squared plus 9? All right, so first thing I always do when I factor is look for a GCF. There is no number that goes into both 25 and 9 besides 1, so there's no GCF to factor out. I see that it has 2 terms. The only possibility for 2 terms, a binomial, is a difference of 2 perfect squares. So a perfect square minus another perfect square. 25x squared is perfect. 9 is also perfect, but the issue comes with this addition sign right here because, again, we want the difference of 2 perfect squares, which means we want a subtraction sign there. So if you have a binomial that's a perfect plus a perfect, that actually does not factor. It is prime, meaning it doesn't factor. All right, let's finish up with the other 2 multiple choice questions here on the back. So it says, which of the following is the complete factorization of this expression here? So first thing I always do when I factor is look for a GCF. So for my coefficients, I have an 8 and a 12. The biggest number or the greatest number that goes into 8 and 12 is a 4. Oops, sorry, is a 4. Then I want to look at the variables. For the variables, you actually want to look for the smallest exponent. So I have an a cubed and an a to the 5th. The smallest of those is a cubed. For b's, I have a b cubed and a b to the 1st. The smallest of those is b. So my GCF is 4a cubed b. It says complete factorization, so I'm going to go ahead and factor that out, or I'm going to divide that out. 8 divided by 4 is 2. A cubed divided by a cubed will cancel out. B cubed divided by b is b squared. 12 divided by 4 is 3. A to the 5th over a cubed is a squared. B divided by b cancels. So I see that my answer for that one is going to be C. For number 8, it says, which of the following is a factor of x squared x squared plus 5x minus 6? So the first thing I want to do is look for a GCF. I have a 1, a 5, and a 6. There is no number that goes into all three of those besides 1. So there's no GCF to factor out. I see that a is equal to 1 here. If a is equal to 1, I'm going to do what's called big X method. On top of my big X, I have a times C. On the bottom, I have B. This is A, B, C. So A times C in this case is 1 times negative 6, which is negative 6. B is a positive 5. So the two numbers that multiply to be negative 6 and add to be 5 are negative 6 and 1. 6 and negative 1. And then I can just go ahead and use these two values to help me write my two factors. So I have x plus 6, x minus 1. So it says which one is a factor? Well, x plus 6 is a factor right here.